All right, Chem 116 students, I'm going to give you a little extra coverage, a few examples of the naming of carboxylic acid salts. Wait a minute, wasn't trying to change that. And how these work. Hopefully these examples will help you as you work on your homework. Any salt is named with its cation first and then the anion. Just think of, for example, sodium chloride, cation first, anion second. And so if we're having the compounds shown here, sodium benzoate and potassium acetate, how would they be drawn? Okay, so sodium is easy, and we only have to draw the cation with its little charge. Fine, but what is benzoate? It comes from benzoic acid, and you change the ending when you've turned it into a salt. And so what's benzoic acid? Benzoic acid must have a benzene ring, right? And in order for there to be an acid on the benzene ring, you have to have an extra carbon. That's what the prefix BENZ is telling you. And if it was benzoic acid, this would be OH, but in this case it's the ion. The anion, the carboxylate ion from benzoic acid. So that's sodium benzoate. If you look at your carbonated beverages, things like Coke, that's not an uncommon ingredient. You might check that out. All right, let's try another one. Potassium acetate. Uh-oh, what's acetate? Well, acetate comes from acetic acid, and that prefix tells you there's 2 carbons in it. And potassium is a simple mono-charged, singly charged cation. And acetate is the anion from acetic acid. 2 carbons, acid. So 1, 2, and what goes on this carbon? Oh yeah, that's the carbonyl, and the O minus. You can also write that CH3CO2 minus in a more condensed form. That's completely valid. Now, another way of thinking about these is where they come from. These are the conjugate bases of a corresponding carboxylic acid. So that's a base, that's a base. They come from carboxylic acids. And so if they are bases, they can react with an acid to reconvert them to the original acid form. So if you were to take our potassium acetate, let's do it this way, CH3CO2 minus, react it with HCl, what would you get? You would get the acid form returns CH3 and this tool, tell that to stop. Don't you love it when technology interrupts you? No, I don't want that. Sorry, guys. So then the acid form returns, you have COOH now for acetic acid, and the potassium ion is going to effectively, whoops, there we go, my tool is being weird, effectively combines with the chloride from HCl to make the second product. Not too tricky. Then let's look at some other acid-base kinds of reactions. Here's one where we have a carboxylic acid with 1, 2, 3, 4 carbons, so that would be butanoic acid. And we're reacting it with potassium hydroxide. Any metal hydroxide is a base. And so remember that the hydrogen that makes it an acid is the last one here, not the ones on the other carbons. And this acid hydrogen will react with hydroxide to make water, but what else happens? Well, the butanoic acid, all the carbons stay together, and we now have the ionized form. So if you have an anion, you have to have a cation to go with it. Well, that would be the potassium. And we would name this potassium, surprise, first name is the cation, butanoate. That ending is indicative of the salt. And the clue that this is a salt is that it has a cation and an anion. This type of ending will also be used for esters in our later conversations. And so don't be confused by which one is which. Salts always have cations and anions. So this, in this particular case, this salt has a cation to go with the carboxylate anion. All right. Oops. Now, if I advance the tool, I will probably show that, yeah, I wasn't trying to put this all here, make it, I wish that could go away, sorry guys. I'm not used to this tool. So if we look at the next example, and you could, oh, well that's the name of the next compound. Oh, I was going to ask you the name, I apologize. So why is this 2-methylpentanoic acid? Well, let's sort it out. 1 carbon has next to it 2 with a methyl group on it, 3, 4, 5. Again, as always, draw them out if it's not clear right away. So this is 2-methylpentanoic acid, and this is just a funny example from the textbook. Reacting with a different base. Any metal hydroxide, that's going to be your base. And this is the acid, right? And if you react the base with the acid, you lose the acid proton, combines with hydroxide. Oh, but guess what? There's 2 of them. And so it will take 2 of these to make the balanced reaction. We don't always have examples where we balance. And so water is left over. Oh, I should write 2 waters, right? Let's do that correctly. Plus 2H2O. And that means the calcium goes with the anion. And it's calcium plus 2. And so 2 singly charged anions go with it, 2 plus. And so what do we write? CH3, CH2, CH2, C with a methyl group stuck on it, and now it's COO minus, but there needs to be 2 of them for this particular example to make the formula correct, because you have a plus 2 cation for the calcium. You have to have a pair of the anions to make sense of it. Hopefully that helps you a little bit as you're working through problems, acid-base reactions, and naming the compounds. But let's name the product before I overlook that. So the product's name is going to be cation first, calcium, doesn't have to be capital, I just did. And the last name is going to be really funny because it's almost like the acid, but now we changed the ending. So it's 2-methyl pentanoate. So that is not too complex, but that's how it works. All right, I hope this helps you with your homework. Good luck as you study for the next exam.